Well, to everybody
Thank
who is with us virtually, I want on behalf of both the Northern New England Clinical and Translational Research Network and the University of Vermont Cancer Center to welcome Dr. Doug Lowy. And Doug, this is not a formality. This welcome is an expression of appreciation first for your willingness to make a virtual presentation, but more important because what you are going to present illustrates how you can translate collaborative team science from discovery to really advances that have had a major impact and will continue to have a major impact both on public health as well as on cancer prevention. So you are appreciated and what you do is very much appreciated. What I've done is asked Dr. Kirsten Tracy. She is the recipient of an NCI postdoctoral fellowship. She is working on non-coding RNAs, but what she's going to do now is to introduce Dr. Lowy. Kirsten.
All right. So before we get started, I just wanted to go over some quick housekeeping for this talk. The questions will be answered at the end of the seminar. So please submit your questions through the chat feature, and Dr. Jessica Heath and I will be moderating the Q&A at the end. So it is my distinct pleasure to introduce Dr. Douglas Lowy, Principal Director of the National Cancer Institute, or NCI, and he's also the Chief of the Laboratory of Cellular Oncology in the Center of Cancer Research at NCI. This is a role he has held since 2010. Dr. Lowy has had a long and distinguished career. He received his medical degree from New York University School of Medicine and trained in internal medicine at Stanford and dermatology at Yale University. He has directed a research laboratory at NCI since 1975, after receiving training as a research associate in the National Institute of Allergy and Infectious Diseases. Dr. Lowy's research includes the biology of papillomaviruses and the regulation of normal and neoplastic growth. His joint research with Dr. John Schiller has identified many aspects of the human papillomavirus life cycle, HPV, and their laboratory was involved in the initial development, characterization, and clinical testing of the FDA-approved HPV vaccines. Dr. Lowy's growth regulation research includes prior studies that establish the importance of the RAS gene family in cancer and the main mechanisms by which the NF1 tumor suppressor gene regulates normal cell growth. His growth regulation research is now focused primarily on the DLC family of tumor suppressor genes and their mechanism of action. Dr. Lowy is a member of the National Academy of Sciences and of the Institute of Medicine of the NAS. For the HPV vaccine research, he and Dr. Schiller have received numerous honors, including the 2007 Federal Employee of the Year Service to America Medal from the Partnership for Public Service, the 2011 Albert B. Sabin Gold Medal Award, the 2012 National Medal of Technology and Innovation, and most recently, the 2017 Lasker DeBakey Clinical Medical Research Award. Dr. Lowy has also received the National Medal of Honor for Basic Research from the American Cancer Society and the Science of Oncology Award from the American Society for Clinical Oncology. So please join me in welcoming Dr. Lowy. We look forward to hearing your talk entitled Recent and Future Advances in Reducing HPV-Associated Cancers by Vaccination and Screening. So.
Kirsten, thanks so much for this lovely introduction. And I want to thank Gary and others for the invitation. I'm looking forward to sharing with you a certain amount of information about HPV-associated cancer, talking about screening and HPV vaccination. And I want to thank Jennifer Smith in advance for running the slides. If we could have the first slide, the really important part of that slide is what is in the lower left corner in yellow. The views expressed are my own and do not necessarily reflect those of NCI and NIH. NCI and NIH do not ordinarily have policy positions. But on the other hand, I like giving people my opinion, but I want to make it crystal clear when I do so, this is just my personal opinion. The next slide tells you about my disclosures. I am an inventor of the technology that underlies the HPV vaccines, and that technology has been licensed to the two companies with FDA-approved versions of the vaccine, Merck and GlaxoSmithKline. I will discuss potential off-label uses of the FDA-approved vaccine, that is fewer vaccine doses than currently approved. And I will also mention a candidate cervical cancer screening approach that is not yet FDA approved. I am not advocating either of these approaches that they should be standard of care at the moment, but that they are appropriate areas for research. And then the bottom bullet simply says that I am involved in other technologies that I don't think are directly related to this presentation. Next slide. I've divided the presentation really into three parts. First, to tell you about cancers induced by HPV infection, and that while cervical cancer predominates on a worldwide basis, there are many other cancers, especially in high-income countries such as the United States, that are also attributable to HPV infection. The second is to talk about molecular cancer screening, and that molecular testing is replacing cytology. And then the third part to talk about the vaccine. And the two main take-home messages are that the vaccine is highly immunogenic and that it has induced herd immunity. And we'll go over each of these areas in a little bit more detail. And I hope that there will be adequate time for your questions and comments when we finish. Next slide simply introduces the epidemiology of HPV-associated cancers. And to a large degree, it really depends on where you live. The next slide, if you'll first look on the left side, this shows you incidence and mortality from cervical cancer in different parts of the world. We're focusing here on cervical cancer because globally, cervical cancer is by far the most important HPV-associated cancer. And in low and middle income countries, where about 90% of worldwide cervical cancer deaths occurs, it accounts for about 10% of female cancers. And importantly, in low and middle income countries, it's projected to increase by about 40% every 15 years. If you look on the left, you'll see that the blue on the left side represents incidence, and the red on the right represents mortality. And you can appreciate that in Africa, the top three parts, that the blue is very big and the red is very big because incidence and mortality are very high. If you now drop down to the bottom part, the third below the bottom is North America. So we're included there, but also down there, Australia, New Zealand, and Western Asia. Blue is narrow, and the red is even narrower because the incidence of cervical cancer in the US and other high-income countries is much lower than in Africa, and the mortality rate is also proportionally much lower. Now turn your attention for a moment to the right side. This looks at what has happened over the last 50 years up through 2000 to the incidence of cervical cancer in the United States. And note that back in 1950, before the Pap smear screening was widely implemented, we were a high incidence country, as high as in Africa today. But over the years, thanks to screening and follow-up, we have become a low incidence country. Next slide. This slide shows you the contrast between what is seen in low and middle income countries, where 90% of HPV-associated cancer is cervical cancer, and what's seen in the United States. About 40% of HPV-associated cancer in the US occurs in men, and 60% in women, versus about 5% in low and middle income countries in men and 95% in women. The total number of HPV-associated cancers is estimated to be somewhat over 30,000. HPV 16 and 18 accounts for about 70% of cervical cancers and about 90% of non-cervical cancers. And pap smear screening has reduced cervical cancer incidence compared to what it was by about 90%. And the incidence of HPV positive oropharynx cancer increased more than threefold in a recent 25-year period. The number of non-cervical cancers actually is larger in the US than the number of cervical cancers. And an important difference is that virtually all cases of cervical cancer are attributable to HPV infection, whereas the non-cervical cancers, a smaller percentage of them are attributable to HPV infection. Next slide. So the next slide is from a public service display by the CDC about HPV cancer prevention and the vaccine, that one vaccine plus 2 doses can protect against 6 different types of cancer. And it's the different types of cancer that were shown on the previous slide. Next slide. I'd like to contrast HPV vaccination versus cervical cancer screening. And this is in word form. And the next slide shows you in a diagram. Vaccination can prevent all forms of cancer caused by the HPV types targeted by the vaccine, and they are usually referred to as vaccine types. And different vaccines target different HPV types, as we'll discuss in a few minutes. It is a form of primary prevention. It prevents the cancer by preventing the establishment of new infection. Importantly, the vaccine does not alter established infection. So people who have prevalent or established infection, the vaccine is not going to benefit them for that particular infection, although it could help them to prevent other infections in the future. Cervical cancer screening can prevent cancer development in women with established HPV infection. But obviously, it's just for cervical cancer. It's not for the other cancer types. It's a form of secondary prevention because it prevents established infection from becoming cancerous. And it prevents cancer faster than vaccination, but it's less efficient overall than vaccination. Next slide. This slide basically summarizes these 2 different approaches, with vaccination needing to be given earlier in order to have the maximum impact, and screening to occur for women who have established infection. And note that the natural history is universal. It's the same in high resource settings and low resource settings. And these approaches really combined have tremendous power of trying to prevent cervical cancer, and for vaccination, the other cancer types. Next slide. We're now going to go on to the area of cervical cancer screening. And the overall point is that molecular testing is replacing the pap smear. Before we get to that, in the next slide, it really shows you what has happened over the last years in terms of cervical cancer incidence. Jennifer, next slide, please. If we first look on the left, this looks at cervical cancer incidence. On the top with the blue line is Black women, and on the bottom with the green line is white women. Back in 1975, the incidence of cervical cancer was about twice as high among Black women as among white women. But over the ensuing period, has taken a long time, but the incidence of cervical cancer now for white and Black women is quite similar. But note, however, especially when you look at white women, and we assume the same will happen with Black women, with current screening technology and uptake, we've essentially hit a plateau where we have between 10 and 15,000 cases of cervical cancer per year. If you now look on the right side at the boxed area, this looks at cervical cancer mortality. And what I want you to appreciate is that cervical cancer mortality in Black women is about 50% higher than in white women, with Hispanic and Native American women being in between, and Asian Pacific Islanders a little bit lower. So there's still a lot of work to do. And it's probably because Black women end up having their lesions diagnosed at a later period than white women, that is the main explanation for their having a higher mortality rate. My own feeling is that if we could change the technology or the approach, that this might help. And currently, the FDA is working with the NCI to consider self-collected vaginal specimens for cervical cancer screening. And if the FDA were to approve it, it could enable screening of hard-to-reach women, which we think might be able to decrease cervical cancer incidence and mortality. Next slide, please. So this slide simply references for you the Prevention Services Task Force recommendations currently, which is for HPV-based testing either every 5 years for cervical screening for women aged 30 to 65, or cytology testing every 3 years with a wider age group, younger women. But up in the blue part, in HPV-based testing for cervical cancer screening will identify more HPV infections with precancer than will cytology. And I have a little bit about that in the ensuing slides. Next slide. This slide tells you that many HPV positive infections are self-limited. They will go away on their own, especially in younger women. And they do not need to be treated because they are not yet precancerous. But HPV testing, while it's very good at determining whether a woman is HPV positive or negative, is not sufficiently precise in determining whether a woman actually has precancer. And so there is a need for ancillary testing. And this is for triage of HPV positive women by identifying the clinically important infections. Last year, the triage test of P16 expression and Ki67 was approved by the FDA. And there also are ongoing other candidates for triage testing, such as viral DNA methylation and viral E6 protein. They are still experimental. Next slide. At the NCI, Nico Van Vensen and Mark Schiffman are studying a number of different approaches for screening that tend to be molecularly approaches, or to be able to be scalable and suitable for high resource or low resource settings. And I want to show you some data. The next slide is taken from their paper from 2015, which really established that the P16 and Ki67 so-called dual stain positivity could distinguish between women who were HPV positive, who needed to go to colposcopy, and those women who did not. On the top part on the right is shown for SIN2 or worse cytology, and the bottom part in B is SIN3 or worse. And what I hope you can appreciate, the dotted line is the threshold for colposcopy. And if women were positive for this dual stain, they clearly should be, their risk is such that they should be referred for colposcopy. A recent advance is that this approach can be automated, and so this makes it that much more efficient and easier to carry out. Next slide. This slide talks about the recent American Cancer Society cervical cancer screening guidelines. They are more recent than the Prevention Services Task Force, and they don't replace the task force. But they say that women, instead of starting to be screened at age 21, that they should start to be screened at age 25. And this is in large part because HPV vaccination is leading to it being safe for women to start screening at age 25. The second point is that herd immunity in the United States, which I'll discuss in a few minutes, enables screening guidelines to be the same for vaccinated women and for non-vaccinated women. And they recommend HPV-based screening every 5 years if a woman is negative. And to have the management include the triage markers and to use molecular testing. This approach is all based on risk and based on molecular testing. It is not based on pap smear screening. During the question and comment period, happy to talk about this more. Next slide. I'm now going to turn to HPV vaccines as the last topic. Next slide, please. As Kirsten mentioned, John Schiller and I have had a long-term collaborative relationship. We've worked together for more than 30 years. And the research really has, at least from my perspective, my research has benefited enormously from this partnership. Next slide. When we were looking at what technology might be useful for developing an HPV vaccine, Reinhard Kernbauer, who was a postdoctoral fellow in the lab, did the vast majority of the experiments. Reinhard is currently a professor in the dermatology department at the University of Vienna in Austria. But what Reinhard did was to insert the coding region for the major structural viral protein in a recombinant baculovirus expression vector, express this in insect cells, and it led to spontaneous assembly of 360 copies of L1 into virus-like particles. And the transmission electron microscopy next to Reinhardt's photograph is shown for HPV-16 VLPs. These virus-like particles induce high titers of virion neutralizing antibodies. This is the class of antibodies that usually are protective for most preventive vaccines. And importantly, the vaccine is non-infectious and non-oncogenic. Next slide. This slide depicts for you in diagrammatic form the various FDA-approved HPV vaccines. HPV 16 and 18 together account for about 70% of cervical cancer and a higher percentage of the non-cervical cancers. HPV-2, or Cervarix, which is made by GlaxoSmithKline, targets HPV 16 and 18. HPV-4, or Gardasil, which until a number of years ago was the most widely used HPV vaccine in the United States, targets HPV 16 and 18 with virus-like particles, but in addition also targets HPV 6 and 11, which together account for about 90% of cervical cancer. And I'm going to show you one piece of data that uses genital warts because HPV 6 and 11 cause the vast majority of genital warts. I'll show you one piece of data about that. The second generation HPV vaccine called HPV-9 or Gardasil 9 is made by Merck. And it has replaced Gardasil, and it is the only HPV vaccine available for sale in the United States, although the other two vaccines remain FDA approved. Gardasil 9 targets the 5 additional most oncogenic types when it comes to cervical cancer. And so it can prevent about 90% of cervical cancer and a higher percentage of the non-cervical cancers. Next slide. It's very important when you're giving a vaccine to a normal population to make sure that there aren't really serious side effects when given. So this is a review from a number of years ago by the CDC, and I've bracketed for you in the abstract. Safety data have been reassuring with no confirmed safety signals identified. And it remains similar to up until today. And it has been reviewed by a number of other groups subsequently. Next slide. This slide summarizes for you 3 salient results from the vaccine trials. The initial vaccine studies used 3 doses over 6 months. The reason was there was no precedent for an effective vaccine against a local sexually transmitted disease. So you wanted to give as many doses as possible to maximize the likelihood of success. Now it's been approved just for 2 doses for younger adolescents up through age 14. But it was, I think, very reasonable to try to maximize success given the lack of a track record with other vaccines against local sexually transmitted diseases. The vaccine has very high efficacy. It can protect against the vast majority of cancers attributable to HPV infection. Importantly, the vaccine confers sterilizing immunity in most vaccinees. That is, it actually prevents infection. Most vaccines, successful vaccines, don't confer sterilizing immunity. The people still get infected, but it prevents disease. The HPV vaccine works, if you will, upstream from that by preventing infection in most vaccinees. Next slide. This slide essentially shows for you what the potential benefits are for the initial vaccines that targeted HPV 16 and 18 versus Gardasil 9. So the way that this table is set up, cervical cancer is on the bottom, and in situ cervical cancer or high-grade dysplasia is set up on the bottom. Let's look at the top first. In the first row, HPV 16 and 18, note that white women, Black women, and Hispanic women, the percentage of cervical cancers that are expected to be prevented by the vaccine is very similar, and that is about 2/3 of cervical cancers. And if you look at the increased value in terms of cervical cancer prevention of adding the 5 additional types to Gardasil 9, it also is very similar, between 12 to 18%, depending on the race and ethnic background of the patient. But if you now drop down to the bottom part, in situ cervical cancer, the modeling suggests that there's going to be a very big difference in terms of protection against high-grade dysplasia among white women versus Black and Hispanic women. The most dramatic difference is between white and Black women. HPV 16 and 18, although it accounts for a similar percentage of cervical cancer between white women and Black women, when you look at moderate or high-grade dysplasia, it accounts for a much smaller percentage among Black women. And if you look at the Hispanic women, they're kind of in between the white women and Black women. These data, by the way, are taken from the largest study of cervical cancer that has been produced in the United States, and the largest study of cervical precancers from the CDC and other colleagues by Mona Soraya and her colleagues. So if you now drop down to the additional part represented by the addition of Gardasil 9, you actually see that the benefit the added benefit of Gardasil 9 versus Gardasil is higher for Black women and for Hispanic women than it is for white women when you're just looking at cervical dysplasia. But when you looked at the total amount of cervical dysplasia that is prevented even by Gardasil 9 is not quite as much for Black women and Hispanic women as for white women. None of this information was known when the vaccines were being developed. And I don't want anyone to think that this was known and that Black and Hispanic women were disadvantaged. These are all results that came out since the vaccines were developed. Next slide. This slide shows you what has happened in the United States as well as in the New England states that you all represent in terms of HPV vaccine uptake. I have the control on the right for meningococcal vaccination, and let's just say it's high. And let's also say there that urban versus rural, there is actually a difference throughout the United States. If you see 89% versus 83% for the entire United States. And for children who are from at poverty or above poverty families, there's also this similar difference, 89 versus 83. For children who are from families that are below poverty, there's actually no difference between urban and rural. Let's now turn to HPV vaccination. The difference between urban and rural is even greater for HPV vaccination. If you look at the United States wide, 72 versus 64%, or if you look at urban versus rural for children from families that are at poverty or above poverty, 71 versus 63. But once again, for children who are from below poverty, urban versus rural, there's a narrower difference, 76 versus 73. Now let's look at the data for Maine, Massachusetts, New Hampshire, and Vermont, and I've simply listed them alphabetically. And there's clearly a lower vaccine uptake in Maine than in Massachusetts, New Hampshire, or Vermont. And the data don't distinguish between urban and rural, but I've been exchanging emails with Gary Sine and Jennifer Smith recently, and there clearly is this discrepancy of lower uptake in the rural areas in Vermont compared to the urban areas in Vermont. Next slide. Relatively soon after the vaccine was introduced, you could actually appreciate with young women that there was a substantial decrease in cervical cancer dysplasia or precancer. These are data from 2011 that the vaccine was approved in 2006. These are data with Gardasil. And the vaccine was given to young women starting in 2007 in Australia. It was made available free of charge to women up to the age of 26. And you can appreciate that by 2010, among women who were less than 18 years of age, and at that time in Australia, they got screened for cervical cancer, their dysplasia went way down. By contrast, the women who were 26 to 30 years of age, who had not received vaccination, their incidence did not change. And subsequent follow-up showed that this also could be seen for the HPV vaccine types as well. Next slide. It has taken 9 additional years to actually see that there is a decrease in cervical cancer incidence. These data were just published last month in the New England Journal of Medicine, and these are data from Sweden. And that's because it takes a long time from the time you get vaccinated until women start to get cervical cancer. And what I'd like you to appreciate is first, the unvaccinated number of women, you start going up, and this is just women through age 30, the cumulative incidence continues to go up as shown in the orange solid line. Now let's drop down to the dotted green line on the bottom. This is the women who were vaccinated before they were 17 years of age. There's about a 90% decrease in their incidence of cervical cancer. If you now look at the interrupted blue line in between the orange and the dotted green line, these are the women who were vaccinated between the ages of 17 and 30. And their decrease in cervical cancer is only about twofold. Almost certainly, the reason for this is that because the women were vaccinated at an older age, many of them were already HPV positive. And as I mentioned, the vaccine doesn't alter the natural history of women with established HPV infection. To me, this slide brings home how important it is to vaccinate people before they become sexually active. Next slide. This slide shows you from a paper published in 2018, what has happened for trends in sexual activity in the United States among high school students. Needless to say, of course, sexual activity goes from the lowest at the 9th grade to the highest at the 12th grade. And what you can appreciate is that between 2013 and 2015, there was some decrease in the percentage of students that were sexually active. However, by the time that students are in the 10th grade, let's say 4 out of 10 are sexually active, and the time that they're in the 12th grade, about 6 out of 10. So in the United States, it's really important to try to vaccinate people before they become sexually active. And this just gives you some data about that. I just want to make sure that while these data are relevant for the United States, they have absolutely no relevance to our children or our own grandchildren. Next slide. This slide tells you about Henrietta Lacks, an unfortunate woman in the early 1950s who developed an HPV-18 cervical adenocarcinoma and died rapidly from it. We know now, obviously, HPV-18, nobody knew that HPV even caused cervical cancer at that time. We know now that about 90% of cervical adenocarcinoma are caused either by HPV-16 and 18. And we also know that HPV testing can be quite good at identifying HPV-16 or 18 precancers for adenocarcinoma. And what I think is the take-home message here is first, that her cancer should now be preventable by HPV vaccination or by HPV-based screening. And second, if you look on the right, this is The Immortal Life of Henrietta Lacks by Rebecca Skloot that won the Pulitzer Prize a number of years ago. And it not only tells you about an extraordinary story about the Lacks family, the unfortunate story of Henrietta Lacks and her cancer, but it also tells you about medical ethics as related to clinical trials, et cetera, and its development since the 1950s. It's a terrific book. I recommend it for any of you who have not had an opportunity to read it. Next slide. The next two slides talk about really the mechanism of action of the vaccine. Why is it so protective? And the reason is because it induces high levels of neutralizing antibodies. On the left is shown a reconstruction electron micrograph of a papillomavirus particle, and on the right, superimposed on it, is a neutralizing monoclonal antibody that binds to the virus. And you can easily appreciate how the binding of the antibody to the virus could interfere with infection. And indeed, that is what happens. The next slide, which is an animated slide, tells you about the mechanism as shown experimentally. A number of years ago, we developed a mouse challenge model for HPV infection. And this is looking at a mouse that has been immunized with HPV-16 and at the genital tract of the mouse. The little Ys in the dermis are the high level of antibodies that are in the dermis of the immunized mouse. And this is the intact mucosa of the vaginal epithelium of the mouse. And there are low levels of antibodies in the intact epithelium. In order for HPV to infect the epithelial cell, you need to have abrogation of epithelial integrity. And that's shown with the first animation. And then with the next animation, it shows you that because the integrity has been abrogated, the antibodies in the dermis now go into that area of potential infection. The next animation shows you what happens when the virus particle comes in. The next animation shows that the antibodies in the mucosa actually find the virus. They neutralize the infection, and at high antibody levels, as shown in the next animation, they prevent infection. You'll note that the infection actually starts on the basement membrane, which is shown between the epithelium and the dermis. In contrast to most viruses, papillomaviruses start their life cycle on the basement membrane. They undergo a conformational change and an enzymatic cleavage of the virus particle that then enables it to bind to the cognate receptor on the epithelial cells. But all of that is interfered with at high levels of antibody. Next slide. This slide is, I think, really important from a conceptual point of view, which is really what should we be thinking about for vaccination in less developed parts of the world versus more developed parts of the world. My own view is that the main purpose of vaccination in the less developed areas is to protect against cervical cancer. And therefore, that female vaccination is most cost effective. If there were plenty of resources, you could easily imagine vaccinating both genders. But because cervical cancer accounts for 90% of the cancers, to me, it seems most cost effective to do female vaccination. In developed countries, however, we want to protect both males and females against the range of HPV-associated cancer. And although female vaccination with high uptake would be most cost effective, adding male vaccination can confer even greater protection for vaccinees than can herd immunity alone. But an additional reason is with male vaccination, if you don't have male vaccination, it's going to take a very long time to reduce the HPV reservoir in men who have sex with men. So that these are some of the reasons for wanting to maybe have two different perspectives on HPV vaccination. Next slide. The goals of HPV vaccination really are twofold. One, to directly reduce the risks of infection and disease in vaccinees, and the other, to indirectly reduce the risk by reducing the prevalence of the vaccine types in the general population, or what's referred to as herd immunity. We've talked already about how the vaccine can protect vaccinees. The next two slides talk about herd immunity. This is a slide taken from the experience in Australia, and we're using as the endpoint genital warts. But instead of looking at genital warts in women, we're looking at genital warts in heterosexual men. And what I hope you can appreciate is that by 2010, in heterosexual men who were less than 21 years of age, as shown in the blue line on the bottom, or heterosexual men who were 21 to 30 years of age with the interrupted red line, there was a drastic difference in the incidence of genital warts among those men. This is a clear example of herd immunity. And the men who were over 30 years of age, who were heterosexual, there was no such change, presumably because they had relatively less exposure to women who had been vaccinated. Only women were vaccinated in Australia during this time period. And again, confirmation with HPV testing for this result as well. Next slide. This slide simply tells you in word form that by 2016, 10 years after the introduction of the HPV vaccine in the United States, there was a more than 80% decrease in the prevalence of HPV vaccine types among all 14 to 19-year-old women, although only 54% of them had received one or more vaccine doses. And the reference is given here from 2019 from the CDC. But this is really quite remarkable. Next slide. This is talking about whether a single vaccine dose might confer years of protection. Next slide. The rationale for this from a conceptual perspective is that while more than 100 million girls 10 to 14 years of age had received at least one dose of the vaccine up through 2017, fewer than 5% of eligible 10 to 14-year-old girls in low and middle income countries had been vaccinated. And you need to recognize that more than 60 million girls are born annually. And so to control cervical cancer worldwide, we should be thinking about vaccinating 40 to 15 million girls in each birth cohort. That's 40 to 15 million girls each year. So we really need to think about scaling up. And one way of thinking about scaling up is to decrease the number of doses. Next slide. So we have post hoc information from a trial that NCI conducted with the bivalent vaccine in Costa Rica that showed after 11 years after starting this trial, this is with Cervarix, the GlaxoSmithKline vaccine, there was no difference whether the women received one dose, two doses, or three doses. This is post hoc data. So we don't want to change standard of care, but we do want to do a trial that could rigorously control for this to see whether one dose might work. And I'll talk about that in two more slides. The next slide depicts for you what happens with the antibody levels for the women in the trial. 11 years after starting the trial, 100% of the women who received only one dose of the vaccine were HPV-18 antibody positive. Their antibody levels have remained positive for a long time. The antibody levels are not as high as the women who received two doses or three doses, but we think that these levels of antibodies might be high enough. And note that they're about 9 times higher than the antibody levels from natural infection that occurs after natural infection. Next slide. So 3 years ago, we started a large clinical trial, an efficacy trial in Costa Rica. This is a new Costa Rican trial, and it's partially supported by the Bill and Melinda Gates Foundation. And what we're doing is that we are comparing the effectiveness of one dose versus two doses of two FDA-approved vaccines, Gardasil 9 or Cervarix. The women have all been enrolled in the trial, And we hope to get a readout about efficacy in another 3 years to see what happens. But if one dose proves to be highly efficacious in this prospective trial, we think that really this could be transformative in low and middle income countries for vaccine implementation, and also could save a great deal of money. We estimate, for example, saving about $300 million in the United States if the United States were to go to a one-dose vaccine schedule. Next slide. This is my second to last slide. And I want to, although needless to say, it's very important for us to vaccinate people in the US and elsewhere. This is a modeling study from the Harvard School of Public Health by Jane Kim and her colleagues. And what it does is to basically do a thought experiment. What happens if you scale up vaccination to 90% versus scaling up screening to 90%? And it turns out with this modeling study, you could go down to 4 cases per 100,000 women, excuse me, much faster with screening, about 10 years faster than with vaccination. So vaccination is important, but screening is also important. And we really should think about what we can do to increase screening for eligible women. The last slide tells you that population-wide vaccination could be an opportunity for people to begin to get up to date with their prevention and screening. And this approach might be especially useful for people who are underinsured and uninsured. And it could include prevention and screening beyond cancer. The summary slide is really to just highlight basic research led to identification of HPV as the cause of cancers, to the development of the vaccines, and to molecularly based screening. The virus-like particle display is highly immunogenic, confers long-term seroprevalence from a single dose. The vaccine can readily induce herd immunity, and control of HPV-associated cancer as a worldwide public health problem may soon be feasible. Thanks so much for the invitation. I hope that I've left some time for us to discuss things. I know you may have questions, but also I welcome your comments.
Thank you so much, Dr. Lowy. We haven't had any questions in the chat box so far. If folks on the call have questions or comments for Dr. Lowy, please feel free to enter them into the chat box and let us know. While we wait, Dr. Lowy, I wonder if I could go back to an earlier slide that you had presented that showed over time the gap in cervical cancer incidence between Black women and white women had narrowed, and there was no longer a difference in incidence, but there was still a difference in mortality. And I wonder if there's data to explain that difference in mortality, particularly including the ways in which systemic racism in medicine, which we've been, our eyes have been more open to, at least mine have over the past year, may play a role in that.
I think that there's probably 2 factors. One is access to treatment, okay? But I think it's also important to recognize that Black women, when they have their cancers diagnosed, they tend to be at a more advanced stage. So those are probably the two main factors. And it's thought that on the order of 40% of cervical cancers occur in women who have not been screened according to guidelines. Okay, so they're under-screened women. And that's why my own view is that if we could make it easier for under-screened women to get screened, that might help in the short run. In the long run, vaccination will probably take care of things, because there's no real difference in vaccination rate between Black women, Hispanic women, and white women. If anything, it's higher among Black and Hispanic women than among white women. But it's going to take a long time for that to take hold.
Thank you. There is a question here in the chat box. If being vaccinated, even with only one shot, has higher antibody production than natural immunity, should it be recommended that people get vaccinated even if they may have been exposed already to HPV?
Yes, that's an important question. The short answer is yes. And the reason is that probably if you recover from an infection that due to HPV-X, let's say, the chances are, even if you once again get infected by that type, you'll probably clear that infection again. But because the HPV vaccine is a multivalent vaccine, just because you've been infected with HPV type X, we think that most protection is so-called type specific. So if you've been infected, let's say, with HPV 18, and but there are 8 other HPV types with Gardasil 9 that you haven't been exposed to, it should be really cost effective for you to be vaccinated with something like Gardasil 9 to protect against those other HPV types. I can see the question. Question about adjuvant. The Merck vaccine has a standard alum adjuvant, aluminum adjuvant. GlaxoSmithKline vaccine has a proprietary adjuvant that's called AS04. It is more immunogenic than the alum adjuvant. And GlaxoSmithKline has said that they are developing a 9-valent vaccine similar to Gardasil 9 that they would plan to use their adjuvant. Okay, but I should emphasize that their adjuvant is FDA approved. Okay, are there health concerns with co-vaccination of young adults for HPV and SARS-CoV-2? I don't think that there are theoretical concerns of co-vaccination, but also there are no, I would say that there are no, there's no experience of giving HPV vaccination with SARS-CoV-2, and I would just follow guidelines about that. The target age group for SARS-CoV-2 right now doesn't include children who are under 16. There are immunogenicity trials that are underway. So the hope is that in a relatively short time that the SARS-CoV-2 vaccines will be approved, assuming that they're safe and immunogenic in children, that they will be approved for younger children. So if a booster, should you get a booster to get the most current vaccine? The Advisory Committee on Immunization Practices has not actually weighed in on this. My own view is, I think the answer would be somewhat age dependent. If it's someone who is still 18 or under, I think it makes good sense to get vaccinated with the second generation vaccine for the additional protection that it confers. If it's someone who is over 21, I doubt that there is sufficient benefit. Okay, and between 18 and 21, I think it's difficult to say. This is just my personal opinion.
Okay,
Uh,
just about 1 o'clock. Dr. Lowy, there's one more question in the chat box if you have time to answer that, and
Yeah.
then wrap it up.
Okay, does it make sense to determine exposure use that? No, no. I mean, right now, I think we should go for 2 doses. That's what has been demonstrated to be correct and to be effective, et cetera. If the data in the future show that 1 dose is sufficient, that's fine. But I think that you're much better off going with what has been demonstrated to work and what is recommended, rather than rather than just saying, well, I think it's going to work, or I'm going to do an assay and do something different. It's just much easier. So anyway, thanks so much for your questions and for listening, and really appreciate it, and thanks for all that you all are doing.
And from
Great,
all
thank
of
you
us,
so much.
thank you.
Yep.
Dr. Lowy, are you staying on to talk with our HPV authors, or do you need to get onto another Zoom?
I'm just rejecting Francis Collins by talking with you. It's not important. For those of you who don't know, he's the director of the NIH. They're having he's doing a town hall, but I have my expert in the booth. My wife is listening to the town hall. Happy to talk with you all. Okay.
I don't know if anyone's able to stay on. I see a few folks, but Gary, do you have anything to add about the HPV grant piece, or shall we let Dr. Lowy go to his town hall?
Well, if our folks have any questions they would like to ask Dr. Lowy, let's utilize this as an opportunity. But if there isn't any pressing question, we're happy to let you go and listen to Dr. Collins. Anyway, thank you very much. This was incredibly informative. You really provided the public health impact. You shared with us how you can actually take discovery and move it step by step. And then once it's out there in terms of clinical application, how it could be reevaluated. So I think there are tremendous lessons learned for all of us. Thanks again for joining us.
Thanks, Gary. I mean, what I didn't tell any of you is I had 0 experience with translational research before doing the vaccine. John and I we had only done basic research up until then, but in part, because of the freedom of the intramural program at NIH, we were able to do this research, and then to kind of follow our, follow where the research led, which really has been to actually doing clinical trials. I never imagined that I would be able to do something like that before we made those discoveries. So Gary, I really think that the freedom of the intramural program is what helped to do it. And what we try to do at NCI, but I think we're quite imperfect, is to try to make sure that people who are extramural also have freedom to do what they to do what they want, and that we provide the resources so that they can do that.
And I very much appreciate what you're saying. I mean, speaking for myself, I mean, I returned to Vermont 10 years ago with really 2 objectives. One was to continue our cancer research program, which in fact is quite robust, but more important was to be able to take on clinical and translational research, working with rural primary care practices. And it's been a learning curve, but I've been able to establish partnerships with folks who are incredibly insightful, incredibly committed and incredibly effective. And so I could really see how you can go from information secured in the laboratory and begin to utilize it in a way that makes a difference.
Yes.
It's really kind of cool. It really works bi-directionally.
Absolutely.
And
So
you're a role model for it.
yeah. So, but anyway, as you go forward, if you have questions, you know, or what things come up, you know, feel free to send me an email. And when I don't respond, then send me a reminder email and say second email or something like or something like that. Okay, I like the road to hell. I am paved with good intentions, but don't always do what I say I'm going to do in that regard.
You've gotten back to me within a half an hour anytime that I've gone ahead and contacted you.
Okay.
So
All right. Take
Thank you
care,
so
everyone.
much.
Thank you.
Okay. Good luck. Bye.